In today's video, we are going to learn about trigonometric ratios. A right triangle has trigonometric ratios, and all acute angles that have common acute angles are similar. The ratios of their corresponding sides are equal. These trig ratios were given names sine, cosine, and tangent. So we could have multiple right triangles that have common angle measures, and they are going to be similar, even though they might not be the same size. They will be similar in how they look because they share the same angle measures. Now, they will also have corresponding sides that are equal. So we could have, say, AB, and if we had a triangle that looked like this, a little bit smaller, this little side, we called it EDF. So AB and FD would be similar, so would BC and DE. You get the picture. So they would be equal. The ratios would be equal, not necessarily the side lengths, just their ratios. These trig ratios that we're going to be learning about are sine, cosine, and tangent. So remember, a ratio can be written as a fraction. It could be written as with the two semicolons or in words. But we are going to be dealing with the fraction portion of a ratio. So for sine, we are talking about, let's say we take the sine of A. Sine, we're going to talk about the opposite leg. Remember the two sides that come together and make that right angle. These are the legs. Okay, and the side opposite the right angle is known as the hypotenuse. So for this angle A, the sine of that angle is going to be the opposite leg, which is 3, divided by the hypotenuse, which is 5. So the sine of A is going to be 3 over 5. For cosine, cosine is the adjacent leg of the angle divided by the hypotenuse. So again, the hypotenuse stays the same as 5, but now adjacent means next to. So the side that is next to angle A is 4, which would be side AB, right? So the ratio would be 4 divided by 5, the adjacent leg divided by the hypotenuse. Tangent of the angle, we have opposite leg over adjacent leg. So for A, the opposite leg is 3, the adjacent leg is 4, so it would be 3 over 4. So those are your definitions of sine, cosine, and tangent in ratio form. A helpful mnemonic that was created a long time ago for remembering ratios is something called SOHCAHTOA. SOHCAHTOA. So if you can remember this ratio and what this mnemonic, which will help you remember your trig ratios, then this unit will be very easy. So sine, which is so S sine is opposite over hypotenuse. So the opposite leg over the hypotenuse. Ca, which is cosine, is adjacent leg over hypotenuse. And toa, which is tangent, is opposite over adjacent. So SOHCAHTOA is a very helpful mnemonic for what we're going to be doing over the next couple weeks. So with that, today we're going to just be dealing with understanding and identifying our trig ratios. So we have a triangle here. We have a triangle ABC. C is your angle, your right angle, okay? C gives us that right angle. Remember, the two sides that come to make that right angle are your legs. This would be your hypotenuse. So this is a hypotenuse, leg, leg. All right, and it all depends on A and B, which we're talking about, whether the two legs are going to be adjacent or opposite, depending on what angle we're talking about. So for our model problem, we're going to be using the diagram here to find these following trig ratios. The sine of A. So remember, for sine, we have opposite over hypotenuse. So the opposite leg is 5 divided by the hypotenuse, which is always 13. So 5 over 13 is our trig ratio for the sine of A. Cosine of A would be adjacent over hypotenuse. So that would be 12 over 13. The adjacent leg is 12. The hypotenuse is 13. And for tangent, we have the opposite leg over the hypotenuse, over the adjacent leg. So it's opposite over adjacent. So that's 5 over 12. These trig ratios will change for when we're talking about angle B. So take a moment to work on your check for understanding. And if you have any questions, you know how